Welcome back, students. This is the session 2 from the playlist of properties of matter. The topic is stress strain curve, and I have written down here 5 important points with regards to this topic. So the first point is the definition of this stress strain curve. That is, the stress strain curve is used to study about the elastic properties of materials. So here I have drawn one figure in which this x-axis represents the strain and this y-axis represents the stress. This is the y-axis, and this is the stress strain curve of a particular solid. Now, in this stress strain curve, this OA is the part of the curve which is a straight line. Why it is a straight line? Because here in this part of the curve, the stress and strain are proportional to each other. That is, stress is directly proportional to strain, and in this part of the region, the material obeys the Hooke's law. That is, since stress is proportional to strain, therefore stress upon strain is a constant which is called the Young's modulus. Beyond this point A, that is from A to B, you can see here that this part of the curve is not a straight line, it is slightly curved. So here the stress is not proportional to strain. So, and here the point B, this point B is called the elastic point, and this point A is called the proportional limit. Proportional limit because up to this point A, the variation in the strain is or you can say the strain is directly proportional to stress, whereas from this point, from A onwards, that is beyond A, the stress is not proportional to strain. Now B is the point which is called the point of elastic limit. That is, from O to B, the material will regain its original state if the stress which is applied on it is removed. That is, if the stress applied on the body is removed, then up to this point B, the material will be able to regain its original state. Or you can say that the material will regain its original shape and size. But beyond this point B, the material will not be able to regain its original shape and size. So this point B is called the point of elastic limit, and this point B is also called the yield point. Yield point means that beyond this point B, the material will not be able to regain its original shape and size. So now this region of the curve, that is from O to B, it is called the elastic region, and beyond this point B, is the region of the plastic region. So from O to A, the material obeys Hooke's law. From A to B, the material the strain is not proportional to strain. However, up to the point B, the material will be able to regain its original shape and size if this stress which is applied on it is removed. And beyond this point B, the material will not be able to regain its original shape and size. So beyond the point B, here I have written that the metal is this deforms plastically. That is the material will continue to deform even if the stress applied on it is removed completely. So that is why this beyond B, the material deforms plastically. The point C is the lower yield point. This point C is called the lower yield point on this curve. And what is this lower yield point? This is the point at which or you can say this is the point of the minimum stress required to maintain the plastic behavior of the material. So this is the point, or the C is the lower yield point, and this is the point of the minimum stress required to maintain the plastic behavior of the material. Now next you can see here that there is a point D. Now this point D is called the breaking stress. Breaking stress means the point D, it is the maximum stress which that body can sustain without breaking. So this is the point, or you can say this is the point of maximum stress which a body can sustain without breaking. And after that, beyond this point D, we get another point. This is the point E, which is called the fracture point. So that is what is the fracture point? Fracture point is the point at which the material fails, or you can say this is the point at which the material breaks or fractures. So this is a simple stress strain curve of a solid, and the most important point here which we have to remember is that from OA to A is a straight line, and here the material obeys the Hooke's law. AB is the part of this curve where the this material does not obey the this Hooke's law, but up to this point B, if the stress is removed, then the material will regain its original shape and size. Beyond this point B, it will deform plastically. That is, beyond this point B, if the stress is removed, then the deformation will continue. This is C, the lower yield point, or you can say this is the point of minimum stress which is required to maintain the plastic deformation, and D is the breaking stress, or you can say this is the point of maximum stress with a solid can withstand without breaking, and E is the point of fracture. Okay, so this is all I have for this session. In the next session I will be discussing about the Hooke's law. So till then, have a nice day. Bye.